So for example, when we select name FR, well, in this case, FR type, comma subtype, we would get back FR type, comma subtype. Now you might be wondering, why is this useful? Because when I select, I already know the name, right? It should be there. Yes, and sometimes no, right? So for example, this length of bracket name here, um, what is actually the eventual, column name that's being returned to us is actually length of bracket name. Now that may or may not be surprising to you because sometimes we may not get back the same name because there are aliases and various other uh, either commands or side effects. And also, at times we might be performing very complicated selects, and in the end, we are not very sure what is being returned. So this would give us a programmatic way to confirm and access the column name of the returned result. In SQLite Studio, when we make a complicated select or simple or complicated select, doesn't matter, we will see the table being presented with the column names on top. So those are the column names that we now can have our hands on. We can actually access them directly. Also, the ordering of the column names can now be ascertained because we did say I want FR type first before subtype. We could have swapped it and this would swap, but swapping it will not change the storage manner, the way we view the schema within the actual database. It's still as it is. Okay, let's move over to our first of all SQLite Studio, where I would like to show just very quickly using our editor tool, all right, what does it mean by select upper? Yeah, so we can say select upper of name and lower of account code, right, from ACCT, all right. So this would return to us two new columns because the original columns are not stored in this casing. So there are two new columns, but they don't occupy storage in the database. They are just created on the fly, derived from the data in the database, and then presented to us. Valkyrie near lower syntax error. So what is going on? Select upper name, lower account code from account. Okay. Yes. Yeah, because it treated it requires treatment as if it were a multi-statement mode. So what happens now is that I got two new columns. They don't exist in the database. They're not occupying storage space in the database, but I actually get them all spelled in capital letters. And now account code, which were stored originally in upper casing, now all converted to lower casing. Let me stress again, these are presented to us in our memory space. They don't occupy the actual storage space in the actual database. So that's something nice. These are all derived, what should we call it? Derived columns. Okay. So obviously we can also say length to create a new column that is integer. Of course, they're all of length 5, right? But not so for the names. Yeah, so we can do that. Yeah, we can also say find in string of this, right? Let's say we are trying to find anything that contains E. Then some would contain E. All right, the second row, this code here, B bank doesn't contain E, which means we'll get a position 0. Remember, 0 is invalid position in SQL because SQL starts with 1. So 0 is to signify that nothing can be found. Row number 6, we have revenue code, REVEN. So the first one starts at second position. That's all. So if multiple occurrences occurred, it will return the first position, first occurrence, and so on. Okay, so we can have fun doing that here. But let's come back to our Python programming window. And now we have a new space, and we would like to perform select, right? And use both the string function and the aggregate functions to test run. So it's good to copy from our previous scripts. Let's just do everything first. Okay, so I have the import changing directory to where we are operating in. You can change it to your own working directory. The database is account.db, perform a connection, right? Then this is the blue column, the blue block, and then finally .close of the cursor and the connection. So in the blue block here, we would like to perform select the sum of all the lengths of the names. So we saw the length of names, right? They count the number of characters in the description. They're all uneven. We would so we would create a new column called length of name temporarily and virtually. So it just exists in transit for the purpose of summing up all together, and then it's gone. Right. So it doesn't take up the storage space. And then when we select this, we can say we don't want to see a column name that's sum length name pretty ugly. We can rename it as total, right, from account. And when we do this, basically we are adding up all we are aggregating up all the length integers together. So as some of you might recall in our earlier on database essential lessons, where we used sum together with group by, right, to perform aggregate summation of each group of items that are grouped together because of certain similarities in values in certain columns. So here, when we did not use it with group by, we can also perform aggregate sum because sum is meaningful. We can do min, max, average. All these are valid applications of the aggregate functions. So we first do that, right? And then we will have all rows, print out the all rows, and then print a line. Then we select the length of name, FR type, and subtype, okay, from account, like this. So we are basically selecting just the length. And we have seen it done in SQLite Studio, so we're just trying it out and confirming it to be doable in Python-driven environment. And finally, after the second select, we would like to query the cursor, right? Can you give me the description of all the columns, please? Right, so like this. Let's run it and see. Okay, so we have, what is this? This is giving us the length, all right? No, this one. So it's giving us the length first of all, and then summing it up. So we only get back an integer. But because we use fetch all always returns a list of tuples. So it returns us a list of tuple of one number. The second select gives us what we have seen in our SQLite Studio, the length of the names, right? If you add up these numbers, these integers, you should get back 103. And then comma FR type, comma subtype, like this. So this is nice. And thirdly, we want to see the description of the columns. So with these information, we have complete and very refined access to each item, right, in the original table. And this is definitely what we are looking at to be able to use purely Python-driven commands to gain access to those items, data items. Okay. All right. In the next video segment, we will look at how we can perform multiple table access of the rows and using joins. Okay. So see you in the next video segment.